Hi guys, in this video I am going to talk about artificial neural model. Basically there are three elements of artificial neural model. First is synapses, second is adder and third is the activation function. Now coming to the first, synapses. A set of synapses or connecting links, each of which is characterized by a weight. We know that these synapses or the connecting lines have a weight associated. A signal xj at the input of synapses j connected to neuron k is multiplied by synaptic weight, and that is wkj, where k represents the neuron and j represents the input end of synapses. That is, we have the signals like x1, x2, so on, signals. These signal, a signal xj at the input of synapses j connected to neuron k is multiplied by synaptic weight wkj. We have sets of input signal. This input signal is given to the synapses, and these synapses have some weight associated for every signal, and which we can represent as wk0, wk1, wk2 and so on, where k represents the neuron to which this synapses is connected, or to which the synapses is connected, and j 1 not 1 2 3 and so on represent the input end of synapses. Second element is the adder, and adder for summing the input signals weighted by the respective synapses of neurons. We have different synaptic weight received by the synapses, w0, wk0, wk1, wk2 and so on. Now we will have a summation or a summing function. This will add all the input weights, and this is our summing function. Now third element of the neural model is the activation function, and activation function for limiting the amplitude of neurons. Whatever will be the total weight of the inputs, now we will have a activation function. This activation function will limit the amplitude of neuron, and the range of this activation function is either 0 to 1 or -1 to 1. And in activation function we have a threshold value theta, and we compare this threshold value theta with our input, and now we decide what will be our output. Suppose we define theta is equals to 0, and suppose now our input I is greater than 0, then we will represent output as 1, and if it is less than 0, then we will represent our output as 0. Suppose our total sum of the weight is 0.9, then we can say our output will be 1. So this is what artificial neural model is. We have input signals x0, x1, x2 and so on, which are given to the synaptics. This synaptics has some weight, and that will be wk0, wk1, wk2 and so on. And now this summing function will have the total sum. We can represent this summation function as uk. Uk is equals to, from j is equals to 1 to p or n so on, wkj into xj. Here wkj is the weight associated and xj is the input signal. In the summation function we have two more values, that is x0, that is our fixed value. We will have x0 as a fixed value that can be +1 or -1, and wk0 as a bk, that is bias. This bias is a externally applied bias, and that has the effect of increasing or lowering the net input of the activation function, whether it is positive or negative. We have this wk0 into x0 so that we can increase or decrease the total value of the input according to our activation function value. Suppose we define theta as 0, and now we will say that if I is greater than theta, we will have the output 1. So we will have this bias function or bias value, so that we can increase or decrease the value according for our activation function, so that it can be fitted in the activation function value. We can represent UK, that is summing value, as UKJ, that is weight, and XJ, that is our signal. But we can also say VK. Here VK is a linear combiner output due to input. We can say X J is equals to 0, summation of from J equals to P, from 0 to P, XKJ into XP. And now we can write this XKJ into XP as WK0 into X0 plus J is equals to 1, summation from J is equals to P, WKJ into XJ. And now we can say this is what our bias is. Then we can represent VK as a sum of bias and the summation function value. So this was all artificial neural model. Thank you.